This is a video response to the question that was posed. When you convert the decimal and you split it into two parts, how do you find out the denominator, like 99, 90, and 990? So for this example, it's rather simple because we're just placing that number over 99. We have a 9 for each place value of the number over here. So if it were simply 0.3 bar notation, it would be 3 over 9, which is the same thing as 1/3. Now that's simple enough if all of your numbers have bar notation over it. For instance, 0.123 with bar notation over the 123, you simply put it over 999, a 9 for every place value. But let's take a look at if only one number has bar notation, and I think that's what the person who sent a message was referring to. Now we can break this decimal up into two parts, a terminating decimal, 0.3, and a repeating decimal, 0.07 with bar notation. Now 0.3 would be easy enough to write as a fraction. That's simply 3 over 10. 0.07, we're keeping the 7 as the numerator, and the question here I think is how do you make the distinction between 90 and 99 for this particular instance? This would be a case where you're doing 90 because you only have one number that's repeating. Now if I had two numbers repeating, let's say the number instead was 0.37 bar notation over the 37, then 37 would be our numerator and 99 would be our denominator because we need a 9 for every number that's being repeated. But because here only one number is being repeated, we only need one 9. And because we only need one 9, we'll need one 0 as a placeholder because we just can't leave it blank. So 7 over 90 is the same thing as 0.07 with the 7 repeating. At this point you need to add the two fractions. We still need to find the least common denominator, or find a denominator that is common. The easiest thing to do would be to multiply 3/10 by 9 over 9. That would give you 27 90ths plus 7 90ths. That's going to equal 34 90ths. And then that gets reduced to 17 over 45. And I guarantee you, if you put this into a calculator, you're going to get an answer that looks just like that. Now let's say we have a 3-digit repeating decimal with only one number repeating. Let's just make it simple, 0.123 bar notation over the 3. I'll go ahead and split this into my terminating part, and that's going to be 12 over 100. And then my repeating part, 0.00, whoops, let me erase that. 3 over 1, 2, and then I need a 9 here because I have one number repeating right up here. Oops. One number repeating, so I only need one 9. If I had two numbers repeating, let's say the 2 was repeating, this would be 990 instead of just 900. At this point, same thing as I did last time, multiply the left fraction by 9, and you'll get 108 over 900, and then we simply just add these two fractions together. 111 over 900. I know they have a common factor of 3 because 1 plus 1 plus 1 is 3. And when you reduce the fraction, you get 37 over 300. Now let's take those same digits, except we'll repeat the 2, 3 instead of just the 3. So I'm going to break this into my terminating decimal over here and my repeating decimal over here. 0, 2, 3, bar notation over the 2, 3. 0.1 is 1/10. 0.23, bar notation over the 2, 3, that's 23. I've got one number here that's not repeated, so that's just going to get a 0. And then I have two numbers here that are repeating, so that gets the 9 for each. So that's where we get the 990. We'll go ahead and multiply the 1/10 by 99 in order to get 990 in our denominator. And then it's just a matter of adding them together. And you'll get 122 over 990. That can be reduced to 61 over 495, and I'm fairly certain that's in simplest form, but in case I'm wrong, don't fault me too much for it. Okay, hopefully that clarifies the question that the person had. I'll see you tomorrow in class.